Well, hello everybody. This dude looks funny, but he got a nice song. This song is about my wife, who is right here in the picture.
That is not me in the picture.
Not in the picture, but in our picture. Anyway, he's just funny to look at though. That's just funny to look at. Anyway, I just wanted y'all to meet my wife. Her name is Chanel, and I just wanted to introduce her because my first video got blocked because I had Julio Jones on there. But this song, She's a Bad Mama Jamma, is about my wife. See, they even know about her in China. Look at that. They know how bad she is in China. But enough of that. It is time for math. So, on that note, she's going to say bye. And now I'm going to teach y'all about angles and bad women or something like that. Alright, so here's what we're going to do. First, we're going to talk about how we classify angles. And it's based on their degree measure. And in this case, an acute angle is an angle less than 90 degrees. A right angle measure is 90 degrees exactly, and an obtuse angle is greater than 90 degrees. And so notice that each one of those is kind of orientated around a 90. You never want to take a picture and assume that it's 90 degrees. You have to be told that it's 90 degrees. And most of the time you'll see a little box, something like this in the corner, or your instructions or directions or something will let you know it's 90 degrees. Otherwise, you can't just assume it's 90 degrees. Now, another thing that's important to understand is how you actually name an angle. You can name an angle with 3 letters, and there's parts of an angle. For example, you have the sides, and the point where the 2 sides connect is called the vertex. Whenever you name an angle, you want to make sure that the vertex is the middle letter. For example, A, B, C. That stands for angle ABC, and what that would look like is A would be up here somewhere, B would have to be the vertex, and C would be over here. The B, the middle letter, is always the vertex. Alright, that's just how to name it. Now, in this case, this particular part right here is called a straight angle. It's a straight line, and its measure is 180 degrees, which is something like this 90 here. If it were to lay flat, it would be 180 degrees, and we talked about that in class today. Now, what we use to measure angles is called a protractor, and I showed y'all that in class. I forgot to put one up on the video, but you can measure any angle with a protractor as long as you put the vertex on the center circle on the protractor. So this side is just an introduction to angles. Now we're going to take angles, which is what geometry does, and we're going to apply some algebra to it. But before we do that, we need to understand congruent angles and an angle bisector. Congruent angles are 2 angles that have the same measure. For example, if I were to, which I can't do because I can't draw. If I had 2 angles like this, and I told you that this angle was 35, and this angle was 35 degrees, then that means that each of these are congruent to one another. 2 angles that have the same measure, and it could be more than 2 angles, but we're talking about angles that have the same measure. An angle bisector is a ray that divides an angle into 2 congruent angles. And my drawing is terrible, but again, an example of an angle bisector would be something like this, even though it sucks. And if I told you this big angle here that was here before, this angle here, if I told you that this angle was 40, and then I drew this line, and now that split it down the middle, that means this part right here and this part right here will both be 20. It will bisect it or cut it into 2 equal parts. That's simply what a bisector is. A ray that divides an angle into 2 congruent angles. So hopefully you understand with my ugly drawing what an angle bisector is and what congruent angles are. Next, let's actually use this example here. It doesn't really have anything to do with congruent angles. It's just more of a continuation of an introduction from the first page. But this example here gives us an idea of how we're going to use angles and how they relate to one another. It says, given that the measure, that means measure, given that the measure of angle LKN equals 145, we want to know the measure of LKM and MKN. And so based on what I know here, let's look at the picture. I'm not starting to write anything yet. I just want to know what I'm looking at. And based on what I'm looking at, I have this angle right here, LKM, and I have this angle right here, MKN. And both of those angles right there, add together to be this one big angle, LKN. Again, I have this little angle here and this little angle here, and if I put them both together, they make this one big angle, LKN. And I happen to know what LKN equals. And so what I'm actually going to do is I'm going to make an equation based off what I see. And one of the things you have to remember this as you're working in geometry, as we started really getting into geometry. Whenever you see things set up, excuse me, whenever you see problems set up and they have a lot of expressions, like 2x plus 10 for this angle here, 4x minus 3 for that angle there, you should already have in your mind that you have to solve an equation. But there's no equation to solve right now, which means you have to make it up yourself. So I'm going to make up this equation based on what I see, not just some crazy idea or just set them equal to one another like some people do. It has to be true with this. I know that the whole thing is 145. They told you the whole thing on purpose because they're going to give you some pieces. So if the whole thing is 145, then I should be able to take the parts and find the whole. So what I'm going to do is take this first part, which is 2x plus 10, and add it to the second part, which is 4x minus 3, and that equals the whole thing, 145. Now you might be confused as to say, where did that come from? Well, let's look at this. I can take the measure of angle LKM, which is this one right here, plus the measure of angle MKN, and that's going to equal the whole thing, which is angle LKN. So each one of these represents those. This part plus this angle equals the whole thing. You're going to have to be able to visualize that and see that as a student. Now, as I work this problem out, you're going to realize again why we start the year off solving equations. Because my next step is 6x plus 7 equals 145, combining like terms. Subtract 7 from both sides. You get 6x equals 138, and you divide both sides by 6, and you get 23. That's not your answer, because they want us to find these two here. But every now and then you'll get a problem and they'll actually ask you just to solve for k. What does that mean? That means before you start working the problem, you actually need to read the instructions to know what it is you're working on, what it is you're trying to find. When do you stop? Because sometimes y'all just keep working and keep working and keep working. Don't know what you're doing. You just work it. What you doing? I don't know. I'm working. No, you got to know when to stop. And I don't stop here because I got to find LKM and MKN. So I go back up here, and LKM is 2x plus 10. Since I know that x equals 23, I'm going to say that the measure of angle LKN equals 2, substitute 23 in for x, plus 10, and that equals 56 for LKN. And I'm going to say the measure of angle MKN equals 4 times 23 minus 3. So 4 times 23 is 92 minus 3, which is 89. And actually both of those should be degrees. So my answers are 56 degrees and 89 degrees. And just for the record, does 56 plus 89 equal 145? Yes, it does, which is what they told me at the beginning. Now, if I went too fast or I didn't explain something good, write your questions down and we'll talk about it tomorrow. Of course, you know you can pause this video or rewind and hear it all over again. All right, let's keep going. Not with this problem. We're going to move on to the video. Given that the measure, that angle KLM is a straight angle, which is very important. We know what a straight angle is, and just in case you forgot, a straight angle is 180 degrees. We talked about that already. Find KLN and NLM. So they want us to know, want to know the degree measure of this angle and the degree measure of this angle here. So I'm starting off with the understanding, and I underlined it here just in case you couldn't pay attention, that this whole line is 180 degrees. 180 degrees. And what does that mean? How do I take that and apply it to this problem? Well, they gave me the parts of the whole. This first part plus this second part, doesn't that equal the whole line? What do you mean? If I start from here and go to here, that's this first angle. And then if I start from here and go to here, that's that second angle. So that's the whole figure here. So we're going to take that idea and now we're going to actually do some work based on understanding straight angles. And so again, just in case you didn't understand what I was saying, if I start here, this is my starting point, and I end here, that means this straight line is 180 degrees. So I can set up an equation based on what I see. Again, why do I want to set up an equation? Because I was given expressions instead of just numbers. If they would have said 180 or a straight angle, and then they would have gave me 62 over here and 100 and something over here, then that would have been okay. I could have just used numbers. But the fact that they gave me stuff with variables or expressions, I have to set up my own equation. So what equation do you set up? Do you set these two equal to each other? No, that's not the rule. That's not what we see here. These two angles aren't equal to each other. I don't have a bisector telling me that these angles are congruent to one another. But what I do know is that 10x minus 5 plus 4x plus 3 equals 180. I do know that. Now you may say, how do you know that? I can take the measure of this angle KLN and add it to the measure of angle NLM, and that equals 180 because that is the whole angle. So you have to be able to visualize. That's something I'm going to keep hammering in, is you got to be able to see what it is you're working on. So as we work the problem, combining like terms, 14x minus 2 equals 180, two-step equation, and it came from combining like terms. And then I add 2 to both sides. I divide by 14. And I believe it's 13 because I done worked this problem out 700 times, but I don't forget now. Yep. X equals 13. Again, this is not my answer. This is just helping me to find my answer, but pay attention to your instructions. If I ask you to solve for X, you would be done. So now KLN would be this angle right here. And so I'm going to take 10 times 13, which is my answer, minus 5. And that's 130 minus 5, which is 125 degrees. And this is for KLN. Okay? So that's angle KLN, actually. And then the other one is 4x plus 3. And so let me put that there, 125 degrees. And then the other one is 4 times 13 plus 3. And that's 55. And again, let's check our work. That's degrees. Does 55 plus 125 equal 180? Well, yes, it does. All right. So we understand that our answer is correct because we checked it. So what's the lesson here? You got to understand what angles are, how to name angles, and how to actually use equations and things that you already know. For example, the degree measure of an angle things of that nature to help you figure out whatever it is that